When most people think of volcanic danger in the United States, one name rises above all others: Yellowstone. The famous supervolcano beneath the national park has captured the public imagination like nothing else, the subject of countless documentaries, headlines, and anxious internet searches, its very name a shorthand for catastrophe on an almost unimaginable scale. But here is a truth that surprises many people, and that is worth understanding clearly from the very start. Yellowstone, for all its fame, is far from the only volcanic threat in America, and it is not even the one that scientists watch with the most immediate concern. The United States is home to more than 160 volcanoes considered potentially active, scattered across the West. The Pacific Northwest, Alaska, and Hawaii, and among them are mountains that pose real and present dangers to millions of people. Dangers that in many ways are more likely to affect American lives than a Yellowstone eruption ever will. This is the story of 7 of those volcanoes, mountains that most people have never worried about, but that scientists monitor closely, each of which could, in its own way, change America. And before we go on, one essential point: none of what follows is a prediction that these volcanoes are about to erupt. They are not. Scientists cannot predict eruptions far in advance, and the great majority of these mountains will spend our lifetimes in quiet. This is not a forecast of doom, but an honest look at the real volcanic landscape of the country. A landscape far richer and more varied than the single famous name that dominates the conversation. Quick honest word before we dive in. A lot of people watch these all the way to the end, love them, and forget the one thing that keeps a small channel like ours alive: hitting subscribe. If you find this fascinating, take 1 second and subscribe right now. It genuinely makes a difference for us, and it costs you nothing. And drop the name of your state in the comments so we can see who is watching. Alright, let's begin. Why America has so many volcanoes. Before we meet the 7 mountains, it helps to understand why the United States is so volcanically active in the first place. Because the reason explains where the danger lies and why certain regions carry more of it than others. Most of America's volcanoes exist because of the movement of the Great Plates that make up the surface of the Earth, and in particular because of what happens along the western edge of the continent, part of the vast ring of volcanic and earthquake activity that circles the Pacific Ocean. Often called the Ring of Fire. Along the Pacific Northwest, a slab of the ocean floor is slowly sliding beneath the edge of the continent, descending into the hot depths, and as it sinks, it releases fluids that cause the rock above to melt, feeding the chain of volcanoes known as the Cascade Range that runs from Northern California up through Oregon and Washington. In Hawaii, a different process is at work, a plume of hot material rising from deep within the earth that has built the islands one by one as the plate drifts over it, creating the great shield volcanoes that dominate the Big Island. In Alaska, the same kind of subduction that feeds the Cascades operates along the Aleutian Arc, producing an even greater concentration of active volcanoes. And in places like Yellowstone and Long Valley, deep sources of heat have fueled the enormous caldera systems that represent the largest scale of volcanic activity. Understanding these processes matters because it tells us that the volcanic threat in America is concentrated in specific regions: the West Coast, Hawaii, and Alaska, and that these mountains are not random, but the visible expression of the deep and ceaseless movement of the planet. With that foundation, we can turn to the 7 volcanoes themselves. Mount Rainier, the sleeping giant over Seattle. We begin with the volcano that many scientists consider the most dangerous in the country, and it is not one that most people would name. Mount Rainier, the majestic snow-capped peak that towers over the Seattle-Tacoma region of Washington state, is a beautiful and beloved landmark, but beneath that beauty lies a serious hazard. The danger of Rainier is not primarily its lava or its ash, but something less obvious and in many ways more threatening: its ice. Rainier is draped in an enormous mantle of glaciers and snow, more than any other peak in the lower 48 states, and this ice sits atop a volcano whose interior has been weakened over the ages by heat and volcanic gases, turning solid rock into weak, clay-like material. The threat this creates is called a lahar, a torrent of mud, rock, and debris that can form when volcanic activity, or even the collapse of weakened rock without an eruption, sends that ice and loose material rushing down the mountain's valleys as a fast-moving river of mud with the consistency of wet concrete. A large lahar from Rainier could travel far down the valleys that lead toward the densely populated lowlands, and the sobering reality is that entire communities in the region are built on the deposits of ancient lahars, meaning the mud has reached those places before. This is why Rainier is watched so closely, and why the region has developed lahar warning systems designed to give people precious minutes to reach high ground. What makes Rainier especially significant is the sheer number of people who live in the zones that ancient lahars have reached, a population in the tens of thousands spread across valleys that lead down from the mountain, along with the roads, bridges, and infrastructure that tie the region together. A large lahar would not require an eruption at all in the worst imaginable case, though an eruption would certainly raise the risk, and this is part of why the mountain commands such attention. Rainier is not erupting and shows no sign of imminent activity, and it may well remain quiet for generations. But its combination of towering ice, weakened rock, and a nearby population makes it a mountain that scientists take very seriously indeed, and it is often named as the volcano in the country whose eruption or collapse could threaten the most people directly. Mount St. Helens, the one that already proved it the second volcano, needs little introduction to anyone who remembers it, because Mount St. Helens, also in Washington state, delivered the most significant volcanic eruption in the recent history of the United States. When it erupted, it did so with shocking violence, blasting away a huge portion of the mountain, flattening vast stretches of forest, sending ash across multiple states, and reshaping the landscape in a matter of hours. The eruption was a national wake-up call, a demonstration that the volcanoes of the Cascade Range are not ancient relics, but living mountains capable of sudden and dramatic activity. What makes St. Helens important for our story is not just what it did, but what it represents, because it is the most active volcano in the Cascades and has shown activity even in more recent years, building up new rock within its crater in a slower, quieter process of rebuilding. It remains one of the most likely of the Cascade volcanoes to erupt again. And while any future eruption may or may not match the scale of its most famous one, the mountain stands as a permanent reminder that these peaks are alive. St. Helens is monitored intensively, its every tremor and swelling tracked, and the lessons learned from studying it have transformed how scientists understand and watch all the volcanoes of the country. It is, in a sense, the teacher among American volcanoes, the one that showed the nation what these mountains can do. The eruption also taught scientists to recognize the warning signs that can precede such an event, the swarms of earthquakes, the swelling of the ground, the changes in the gases escaping from the mountain, and these lessons now guide the monitoring of volcanoes across the country. St. Helens transformed volcanology in America almost overnight, turning a field that had been relatively quiet into one of urgent national importance, and the observatory established to watch it and its neighbors has become a center of expertise that protects communities throughout the region. In studying how St. Helens rebuilt itself in the years after its great eruption, slowly extruding fresh rock to begin constructing a new dome within its shattered crater, scientists gained a window into the very processes by which volcanoes live, rest, and renew themselves. Long Valley, the other sleeping supervolcano Yellowstone, is famous as America's supervolcano, but it is not the only one, and the third mountain on our list is a place most people have never heard of despite its enormous potential. In eastern California, near the popular resort area of Mammoth Lakes, lies the Long Valley Caldera, a vast volcanic depression formed by an eruption in the distant past so enormous that it ranks among the great volcanic events in the geologic record. That ancient eruption spread ash across much of what is now the western United States, and the caldera it left behind is a sign of the tremendous forces that once operated there. Long Valley is not dormant in the sense of being dead. The area has experienced episodes of earthquakes and ground uplift, signs that molten rock and hot fluids still move beneath the surface, and these episodes have prompted careful monitoring and study over the years. It is important to be clear and calm about what this means, because signs of activity at a caldera are not the same as signs of an imminent giant eruption. And scientists who study Long Valley emphasize that unrest can continue for long periods without leading to any eruption at all. Calderas around the world regularly experience earthquakes and ground movement that rise and fall over years and decades without ever producing an eruption. And the monitoring of Long Valley is designed precisely to distinguish ordinary restlessness from any genuine march toward activity. Should the signs ever point toward a real eruption, that monitoring would be expected to provide warning. And the far more likely future eruptions at such a place would be small ones, nothing like the colossal event that formed the caldera in the deep past. The great majority of the caldera's future is likely to be quiet. But Long Valley earns its place on this list because it demonstrates that Yellowstone is not unique, that America holds more than one slumbering giant, and that the volcanic history of the country includes eruptions of the very largest scale in places that today are peaceful mountain landscapes. Here is something I would love to know, and it takes 10 seconds. Which of these volcanoes surprised you the most so far, or had you never even heard of before today? Drop it in the comments, because your answers genuinely help us decide what to cover next, and I read every one. Okay, back to the mountains. Mauna Loa, the largest active volcano on Earth. Our fourth volcano takes us to Hawaii, and to a mountain that dwarfs all the others in sheer size. Mauna Loa, on the Big Island of Hawaii, is the largest active volcano on Earth, a colossal mountain that makes up a huge portion of the island and rises from the ocean floor to a total height that, measured from its base beneath the sea, exceeds even the tallest mountains above sea level. Mauna Loa is a very different kind of volcano from the explosive peaks of the Cascades. Rather than erupting in sudden violent blasts, it typically produces flows of lava that pour out and travel across the landscape, a spectacle that is dangerous in its own way but different in character. The threat from Mauna Loa is primarily to the communities and infrastructure that lie in the paths its lava can take, because when it erupts, the flows can advance toward populated areas, threatening homes, roads, and everything in their path. The mountain has erupted many times through history, and while lava flows generally move slowly enough that people can evacuate, they can destroy property and cut off communities, reshaping the map of the island. Mauna Loa is closely monitored, and its behavior is studied intensively, giving scientists a good understanding of its patterns. It represents a form of volcanic danger quite unlike the others on this list, the slow but relentless advance of lava across a landscape where people have built their lives. And it reminds us that America's volcanic threats come in many forms, from the explosive to the effusive. Hawaii's volcanoes also produce their own particular hazards beyond the lava itself, including the volcanic haze and gases that can affect air quality across the islands when eruptions are underway, a reminder that even the gentler-seeming volcanoes carry risks that reach beyond the immediate path of their flows. And because so much of the population and economy of the Big Island sits on the flanks of these great mountains, the question of where and when the lava will flow is never merely academic, but a matter that shapes where people can safely live and build. Mount Shasta, the giant of Northern California, the fifth mountain, returns us to the Cascade Range. To the towering peak of Mount Shasta in Northern California, a massive and imposing volcano that dominates the landscape for miles around. Shasta is one of the largest of the Cascade volcanoes, a mountain with a long history of eruptions, and it is considered capable of producing a range of volcanic hazards, from ash and lava flows to the lahars that threaten so many of the glaciated Cascade peaks. Like Rainier, Shasta carries ice and snow that could feed destructive mudflows, and its size and history make it a volcano that scientists include among those warranting careful attention. The communities that lie around the base of Shasta and in the valleys below it would be the ones most affected by any future activity, and while the mountain has been quiet in recent times, its geologic record shows that it has erupted repeatedly over the ages. Shasta is a reminder that the volcanic threat in America is not confined to the far northwest or to a single famous peak, but extends down through California, where great mountains stand quietly over towns and highways. As with every volcano on this list, there is no sign that Shasta is preparing to erupt, and its inclusion is not a warning of imminent danger, but an acknowledgement of its size, its history, and its place among the significant volcanoes of the country, a giant whose quiet should not be mistaken for lifelessness. Shasta also sits near important transportation routes and reservoirs that serve a wide region, so that the effects of any future activity could extend well beyond the immediate area, touching water supplies and travel across Northern California. The mountain has built itself up over a long history of eruptions, each adding to its bulk, and the very structure of the peak records a past of repeated volcanic activity stretching back through the ages. That long record is precisely why scientists keep it on their list of volcanoes to watch, not because anything is happening now, but because a mountain with such a history is one whose future, however distant, is likely to include further chapters of activity. Mount Hood, the peak above Portland. Our sixth volcano is Mount Hood, the graceful peak that rises over the city of Portland, Oregon, and serves as a beloved symbol of the region. Hood is one of the most prominent volcanoes of the Cascades, and like its neighbors, it is a living mountain with a history of eruptions and the potential for future activity. Its proximity to a major metropolitan area is what places it on this list, because a significant number of people live within reach of the hazards that Hood could produce, from ashfall to the lahars that could travel down its river valleys toward populated areas. Mount Hood has a record of past activity that has produced flows and lahars, and the valleys that lead away from the mountain carry the evidence of these past events. Like Rainier and Shasta, Hood's glaciers and the weakened rock of a volcanic peak create the potential for mudflows that could affect the communities and infrastructure downstream. The mountain is monitored, and its quiet is watched for any change, but as with all the others, there is no indication that it is stirring toward an eruption. Hood earns its place here as one more example of a major American city living in the shadow of a great volcano, a peak that is at once a scenic treasure and a geologic force, and a reminder that across the Pacific Northwest, beauty and hazard stand together on the horizon. The mountain is a playground for skiers, hikers, and climbers, its slopes crowded with visitors through the year. And this constant human presence on a living volcano is itself a striking feature of the region, a testament to how thoroughly people have woven their lives around these mountains, treating as recreation the very peaks that scientists monitor as hazards. Quick pause, because this is worth spreading. If you are enjoying this, tap the like button. It really does help the video reach more curious people. And if you have family or friends who live near any of these mountains, in Washington, Oregon, California, or Hawaii, share this with them because it is genuinely useful to understand what is out there. One like, one share to someone you care about, and let's keep going. The volcanoes of Alaska, guardians of the skies for our seventh and final entry, we turn to a place where volcanoes are more numerous and more frequently active than anywhere else in the country, and yet where they threaten Americans in a way most people never consider. Alaska is home to a great many active volcanoes, strung along the Aleutian Arc and the Alaska Peninsula, and they erupt far more often than the volcanoes of the lower states. Because many of them lie in remote and sparsely populated areas, their eruptions rarely threaten large numbers of people on the ground. But they pose a different and very real danger, one that reaches far beyond Alaska, the threat to aviation. The skies over the North Pacific carry some of the busiest air routes in the world. Connecting North America with Asia, and volcanic ash is extremely hazardous to aircraft, capable of damaging engines and forcing the rerouting or grounding of flights. When an Alaskan volcano erupts and sends ash high into the atmosphere, it can disrupt air travel across a vast region, affecting flights and travelers far from the volcano itself. This is why the volcanoes of Alaska are monitored with great care, their ash clouds tracked and their activity watched, so that aircraft can be warned and kept safe. The Alaskan volcanoes represent a form of volcanic threat that is easy to overlook because it does not involve lava flowing through towns. But their frequent eruptions and their position beneath critical air routes make them a genuine and ongoing concern, guardians of the northern skies whose restlessness can ripple out to affect travel across much of the world. A single large ash cloud drifting over the busy corridors between the continents can force the cancellation of flights and the rerouting of aircraft carrying tens of thousands of passengers, turning a remote eruption in an empty stretch of Alaska into a disruption felt by travelers on the other side of the planet. All right, I know, second time I am asking, feel free to sigh at me. But quickly, if you have made it this far into a video about American volcanoes, you are exactly our kind of person, and a huge number of you who watch have not subscribed yet. That one tap genuinely tips the scales for a small channel, No guilt, just a grateful ask. That is the last time. Promise. Let's finish. What these 7 mountains really teach us, having journeyed from the ice-clad slopes of Rainier to the busy skies over Alaska, it is worth stepping back to consider what these 7 volcanoes, taken together, really tell us about America and its relationship with the fires beneath the surface. The first lesson is one of humility. A recognition that the country sits atop a far more active and varied volcanic landscape than most people realize, and that the fixation on Yellowstone, dramatic as it is, obscures a richer and more immediate reality. The mountains on this list, and the many others like them, are not distant abstractions but real features of the American landscape, standing quietly over cities, feeding rivers, and shaping the lives of the many people who live near them. The second lesson is one of balance and calm, because understanding these volcanoes should not lead to fear, but to informed awareness. Not one of these mountains is erupting or showing signs of imminent eruption as we speak, and the science of volcano monitoring, though it cannot predict eruptions far in advance, has grown remarkably sophisticated, watching these peaks with instruments that detect the earliest signs of change. The systems built to warn of lahars, to track ash clouds, and to monitor the swelling and trembling of the ground give communities a real chance to prepare and respond, and the study of these volcanoes has made the country far safer than it once was. To know about these mountains is not to live in dread of them, but to understand the world we inhabit more fully, and to respect the forces that shape it. The final lesson is one of perspective, a reminder that these volcanoes operate on timescales vastly longer than a human life, that their quiet stretches can last centuries or millennia, and that the odds of any particular mountain erupting in any given year are low. The purpose of understanding them is not to await catastrophe, but to appreciate the living, dynamic nature of the land, to support the scientists who watch over these peaks, and to ensure that the communities near them are prepared for the rare but real possibility of activity. Preparation, in the end, is the answer to the anxiety that a subject like this can stir, because the communities that know their risk, that have warning systems in place, that understand what to do and where to go, are the communities that come through such events safely. The volcanoes cannot be stopped, but their dangers can be understood and planned for, and that is where the real work lies. Not in fear, but in readiness. There is something almost reassuring in this, the knowledge that the country watches these mountains, that dedicated scientists study their every stirring, and that the systems built up over decades stand ready to protect those who live in their shadows. Yellowstone will always capture the imagination, and rightly so. But it is only one chapter in a much larger and more surprising story. A story written across the great mountains of the West, the volcanic islands of Hawaii, and the far northern reaches of Alaska. These 7 volcanoes, each in its own way, could indeed change America, and knowing them, watching them, and respecting them is part of what it means to live wisely in a country shaped. From its deepest foundations,